Today's lesson is going to look at functions that have a restricted domain. Not all functions can use any number for x. So these functions that we see here all have functions that are all real numbers. I can use any number for x and it wouldn't matter. So these four functions, linear functions, a quadratic, an absolute value function, and an exponential function, you can use any value for x that you want. It doesn't matter. So we're going to look at things that are restricted. We're going to look at two specific functions that we looked at already that do not have all real numbers as the domain. So we're going to look at things that are restricted. And I have two basic rules. Rule number one is going to be the denominator rule, and rule number two would be the square root rule. And here are my two functions, 1 over x, where x is in the denominator, and the second function is the square root of x. And they do have restrictions or limitation on what I can use for x. So again, let's look at these two functions. Let's first look at 1 over x. So what is the domain for this function? What's my restriction? Well, my restriction is the denominator can never equal 0. We talked about this earlier. If you go to your calculator and type in any number divided by 0, your calculator is not going to like it. It's going to send out an error message. So what's in my denominator? So in this case, x cannot equal 0. Well, that's terrible. So I'm going to remove that from the domain. So my domain is going to be negative infinity to 0 union 0 to infinity, because all I did was I removed just one number. I just removed 0. That's the only number I had to throw away. Now when I look at the square root function, what's my restrictions for square roots? I cannot take the square root of a negative number. Okay, I could take the square root of 4. I cannot take the square root of negative 4 using real numbers. Yes, back in Algebra 2, you learned that the square root of negative 4 was 2i, but we're not doing imaginary numbers, only real numbers. So therefore, x must be greater than or equal to 0, or what we call non-negative. I can take the square root of 0. The square root of 0 is 0, so that's allowed. So my domain is 0 to infinity, including 0. And technically, I kind of removed about half of the real numbers, if there is such a thing as half of the real numbers. So my two rules are based on having something in the denominator and having a square root. So those are the two rules I'm going to look at. So let's say let's kind of see if I can move this up without making a mark. Okay, so let's say we have something a little bit more complicated. Looks like here I'm going to use my denominator rule. So my restriction is that whatever in the denominator cannot equal 0, or x cannot equal 2. So my domain is negative infinity to 2, union 2 to infinity, because I just removed x equals 2. The one number I removed. Same thing over here. I have this underneath the square root sign, so it's going to be x minus 2 cannot be negative or greater than or equal to 0, or x has to be greater than 2. So my domain is going to be including 2 to infinity, and it's really only using half the numbers. So the denominator rule gets rid of one number, has a very little restriction on the domain, and the square root rule has a much bigger restriction because now you're only kind of using half of the available numbers. Okay, we're going to do some examples. We're going to answer in interval notation. I see right here, what rule should I use? I see this stuff here. I'm going to use my denominator rule. So 2x minus 5 cannot equal 0. I add 5. I divide by 2. So x cannot equal 5 over 2 or 2.5. I don't really care. And therefore my domain is going to be negative infinity to 5 over 2 in union 5 over 2 to infinity. Next problem. I see this over here, and I think I should use the square root rule. So I'm going to make 3x minus 6 greater than or equal to 0. I'm going to add 6, divide by 3. I get x is greater than or equal to 2. And now I do 2 to infinity with a bracket as my domain. Now this next one's a little bit different. I see I have kind of a square root rule in the denominator. So what I'm going to do is make this only greater than 0 because I can't equal the 0. So normally when I do the square root, I make it greater than or equal to the 0. I'm going to get rid of the equal 0 part. So when I do this, I'm going to take my denominator of 5x minus 2 and make it just greater than 0. I'm going to add 2 and divide by 5. So I get x is greater than 2/5. And that means I do parentheses 2/5 to infinity. That is my domain. Next problem looks like I have a couple things going on. Looks like on top I have a square root rule. So I'm going to do 2x plus 3 is greater than or equal to 0. I'm going to subtract 3, divide by 2. So right now I have, based on the numerator, x is greater than or equal to negative 3 over 2. And if I wanted to, that domain would be negative 3 over 2 to infinity. That's what domain I have right now just based on the numerator. But I do notice that I have a denominator. So I have to apply that rule of x plus 4 cannot equal 0, subtract 4, x cannot equal negative 4, and then I ask myself, does this have anything to do with this window? I have this window right now of negative 3 over 2 to infinity, and I say I can't use negative 4, and that negative 4 is not in there, so it has no effect on any of this. So my result for this domain is negative 3 over 2 to infinity. Even though I had to do both rules to make sure myself, that denominator rule had no effect on that smaller window. The square root rule always will make a smaller domain or a smaller window. Domains never get bigger, they only get smaller. So I'm going to move this up, do some more examples. Okay, I kind of have the same thing as before. I see I have a square root rule. I have 3x plus 2 greater than or equal to 0. X is greater than or equal to, subtract 2, divided by 3. I have negative 2/3. So right now I have negative 2/3 to infinity as my domain restriction for the numerator, the square root part. But I do notice that I have a denominator. And I need to do that rule of x minus 1 cannot equal 0, or x cannot equal 1. And then I ask myself, is 1 inside that window? And yes, it is. So I have to throw away x equals 1 from this window in gray, and my final result is going to be brackets negative 2/3 to 1 parentheses union 1 to infinity. That is my domain for that problem. I look at the next one and I look like, okay, I have a numerator. X plus 4 is a numerator. There's no restriction for that. I can use any number I want. But then I do notice that I have a square root in a denominator situation, so I'm only going to use greater than 0. So 2x plus 3 is only greater than 0 because I can't have it equal 0 in the denominator. And then I subtract 3, divide by 2, and I get my final result of parentheses negative 3 over 2 to infinity as my domain. Okay, this last example has to deal when we have composition. A composition is when we take a function and put it into another function. Something you did a lot in Algebra 2, and we're actually going to spend a whole day on it next class, doing compositions. But here are some basic ones. We have 3 functions here. F is 1 over x, g is the square root of 3x minus 1, and h is x minus 2. And there's some restrictions in some of those functions, but the idea is that we're doing a composition. So my composition over here is I'm first going to put the function g into the function f. So when I do that, I say this is equal to f of, well, the g function is just the square root of 3x minus 1. So this means that this whole thing here, the square root of 3x minus 1, goes in for the x into the f function. So when I put this into this f function, it becomes 1 over the square root of 3x minus 1. So that is the composition. And we've done some of this before. Look at this domain, and the idea is that I have a square root in the denominator, but the square root is by itself. So I have a square root in the denominator, just like we did before. So I'm going to take this whole thing and only make it greater than 0, not greater than or equal to 0. So I'm going to take this 3x minus 1 greater than 0, and I'm going to add 1, divide by 3. So my domain is parentheses 1/3 to infinity. So the red is the composition of g into f, and the domain, based on its restriction, having a square root in the denominator by itself, is x has to be greater than 1/3. Next one's a little bit trickier because I have a function inside of a function and inside of a function, and that can happen. So what am I going to do? First, I'm going to put the g function into the h function, and then I'll take that result and put it into the f function. So when I do this, I have f of h, and the g function is, again, the square root of 3x minus 1. So now, this whole 3x minus 1 has to go into the h function right here for the x. So this becomes f of the square root of 3x minus 1, and then minus 2 on the outside of the square root part. And then this whole thing has to go for the x in the f function, so the whole thing becomes 1 over the square root of 3x minus 1 minus 2. So that is the whole composition. Now this is a little bit trickier because I have a couple things going on here. I do have a square root in the denominator, but the square root is not by itself in the denominator. So when I look at this, I do have a square root part. So I'm going to do that over here. My square root rule, because it's not by itself in the denominator, I'm going to use 3x minus 1 is greater than or equal to 0. And I get 3x is well, I could just go add 1 divided by 3, and I get x is greater than or equal to 1/3. So right now my domain would be brackets 1/3 to infinity. I'm allowed to have 0. I'm allowed to have this expression equal to 0 because I'm subtracting 2 from it later. And I could divide by -2. But then, and this is the tricky part, I have this whole thing as a denominator. And my rule for denominators is that whole denominator, which is the square root of 3x minus 1, then minus 2, cannot equal 0. So I take that whole denominator, I'm going to add 2 to both sides, so it can't equal 2. And to get rid of the square root, I have to square it. So I have 3x minus 1 cannot equal 4. I'm going to add 1. 3x cannot equal 5. And then I finally have x cannot equal 5/3. Well, once I get this result, I have to ask myself, is 5/3 part of that earlier domain? The answer is yes. 5/3 is in that window, so I have to throw it away. I have to get rid of x equals 5/3. So my whole domain is 1/3 brackets 5/3 parentheses union parentheses 5/3 to infinity. The stuff in purple is my new composition of the f of h of g of x, putting g into h into f, and in black is the domain for that whole function.